Welcome and hello to our Recurrent Patterns, where we look for interesting patterns in technology, business, and culture. I'm your host, Václav Vinčálek. Today on Recurrent Patterns, we will be talking about technology. And with me here today is my special guest, Barry Briggs. He is notorious CTO, if that's the designation. And right now he's working with a company which is still under the wraps called Charlie Soft. Welcome to the show, Barry.
Thank you. Pleasure to be here.
So for the viewers and listeners who don't know Barry, let me put a few things in context here for you. So Barry started with NASA, then worked for DEC, then he worked for Lotus, which eventually was bought by IBM. Then he worked as a CTO for several organizations and ended up as a CTO for their IT department at Microsoft. He built Lotus 123, Lotus Notes, the first Java-based Office suite, and recently, which everybody can find on the internet, he built CloudSheet, Excel in the cloud, on Azure, which had 2.3 billion elements. So that's just for context. And of course, in his spare time, he's writing books. So Barry, tell us something about yourself, which we don't know.
Which you don't know. Well, you kind of alluded to this, but in my spare time, I'm also a novelist as well. So, I think that I try to balance the technology side of my life with the human side of my life, if you want to put it that way. So I've written a couple of novels. One's about family saga about the Korean War, exploring mine and my wife's family backgrounds. And another one, which we'll probably come back to in a little while, is about trying to understand the communications of another species, in this case, dolphins.
Exciting, amazing. So, but let's go back to technology. We will get to the animals, shortly. You start working at NASA. Now you are working on, secretive company, machine learning, artificial intelligence. When it comes to technology, what over the years, what changed and what did not change? What would be the pattern which you observed over the years?
Well, I think, one of the things that I've observed over the years is the way that technology seems to go through these massive paradigm shifts. And we've been through several of them over the years. Maybe one way to illustrate that is with a story. I recall when I was a boy of 6 or 7 years old, I went into my father's office, and in the back room, they just installed this gigantic electronic device. And it was one of the earliest IBM computers, and it was used in my father's office for accounting and inventory. It required several people to maintain it, people to program it, run the printed reports and so forth. And it was a very interesting and in some ways intimidating device. Well, fast forward a generation or so, and we had Lotus 123, which you mentioned, which really democratized in a lot of ways, a lot of the things that that original, I think it was an IBM 1401, a lot of functions that IBM computer actually did. So, suddenly you had ordinary mortals who were able to do the same sorts of calculations and a lot more that big mainframe computer could do. And so you saw this explosion of activity and computing in the mid 80s as a result. In fact, I had an interesting conversation once with an MIT professor, and he was telling me that in his view, that Lotus 123 in particular had been largely responsible for the great boom in leveraged buyouts and M&A activities by the corporate raiders. And you remember the Richard Gere character in Pretty Woman, during the mid to late 80s, and really kind of just shows that suddenly this power was in the hands of non-technical, computer science professionals, and they were able to do things like, if I buy this for a certain amount, what would be my likely returns, and how long would it take, and try different combinations very easily. And so it led to this explosion in activity. And so what you see is this original breakthrough technology. It's highly complex, difficult to use, and then sort of the gradual, for lack of a better term, decomplexification of it. It kind of goes mass market. And I think we're seeing that today with AI. You know, when AI first really, I mean, AI has certainly been around for a very long time, but thanks to the cloud and its ability to hold capacious amounts of data and essentially the availability of on-demand compute and so forth, AI really started to take off, you know, within the last 7 to 10 years or so. But when we first started using it in the cloud, all that time ago, it required PhDs in computer science. It required people who had been trained in mathematics and so on. And what we're seeing now is the gradual commoditization of AI, the ability to put AI and the power of machine learning into the hands of ordinary mortals. And you know, you mentioned my startup. That's what we're really focused on, is being able to take AI and put that into a metaphor that most ordinary business people are very familiar with. In this case, a spreadsheet.
Yes. You touched on a very, I think, critical piece, which is the term you use, the democratization of technology. That over the years, and definitely that's a pattern which, when you put it this way, really shows how from mainframe, which was untouchable by majority of people, which was not even for the 1%. We move into the personal PCs or the personal computers, PCs. We move to now cloud, where all the raw power, which before we could not do, we could not use. Now it's available basically anybody without even a credit card.
Right.
And anybody can go to either Azure or Amazon or whatever cloud provider you have and can start working right away. So I think that's definitely that's very interesting.
We're actually seeing, you know, computing emerging now as almost a very similar thing to a dial tone. It's just there. The ability to compute, the ability to store data, the ability to run applications and perform analysis and so forth. It's simply there. It exists, and all we have to do is tap into it. Much in the same way that, you know, when you pick up a telephone, you don't so much anymore, but you know, with a cell phone. But in the old days, you would pick up a phone and hear a dial tone, and it was just there. It was just available for you to use.
Yes, and you know, my argument always, or you know, when I describe the people, the technology, I said that it's not full circle; it's more like spiral. But
that's a good analogy.
We move from mainframe and basically to cloud, which, for all intents and purposes, again, it's a mainframe where you send tasks to be computed, and somehow it happens, right? So the same thing.
Yeah.
Now, you work for a variety of companies and with variety of technologies. I mentioned a few of these, and what would be so until now we were talking about let's say the computing, the power and how we use it, and then when it comes to the technology itself, you know, you work with myriads of programming languages, different type of architectures. What are the things which because you have the maturity of time, you have now perspective compared to people who are just starting with, you know, being technologists.
Yeah.
It's the same thing now.
When I learned programming, I learned it in an unusual way. I actually had a role in the U.S. government. It was very minor and it was boring. And so to alleviate the boredom, I took a few internal courses in various topics about which I knew nothing. And one of those was on a topic which was called digital design. I had no idea what that was. And so when I took the self-paced course, I opened up the workbook and I learned about this concept of an AND gate and an OR gate. and how you could kind of stitch them together using Boolean logic to do interesting things like addition and subtraction, and you could build memory circuits and registers and so on. And I always thought that that foundation gave me a great perspective for how to think about programming, because once you actually understand at the most foundational level what a computer is actually doing, which is moving and combining bits in interesting ways, then a lot of this makes a lot more sense. And so it makes it possible for programming languages to be very, very intuitive, and you can understand sort of what they're all about, how the computer works, and makes your own programs that much more efficient.
Yes, and again, this is very, very close to my heart, what you described. Maybe we were lucky, or maybe because we were just at the beginning, we had to really learn the programming right from almost the bottom, which was, machine code or assembler, or I remember my days with C. And from there, it was actually much easier to build above that foundation. There was new programming language, there was new concept which we had to learn, but because we had these basic blocks on which we were able to build stuff, that was much easier.
It's certainly one of the areas where I disagree with sort of the modern way of teaching programming, which is just to dive right into JavaScript or Python or Java or whatever. And I actually have a presentation that I give on how a computer works. And the first slide of the presentation shows a faucet, just like an ordinary garden hose faucet. And I say, if you can understand how this faucet works, and you certainly can understand how computers work. And if you think about it, a faucet is either flowing water or it's not. So, and so you turn it on, turn it off, 1 or 0. And then if you string them in series together, you get AND gates. If you string them together in different ways, you get OR gates. And you can actually kind of build up through a series of faucets an adding circuit. Whether you really want to do that in practice is not, I don't know, because you could really run up a water bill, but you get the idea.
Yeah, exactly. And this is the observation which I have, and maybe we sound like two old farts talking about, the past, which never comes back. And everybody say, why would I start with these basics where I can just go and learn the latest programming language? And what I found over the years, it's very similar to just human language, where each language describes the reality around us slightly differently, or it's suitable for, better to describe things. And the same comes with languages. And people who see that, oh, you have to learn this language because this is the latest. And one thing that they don't kind of maybe understand is that one of the past languages is still used today, and without it, the world won't run. COBOL.
Yeah, and it's ironic that there's a great need for COBOL programmers now, as many state governments have antiquated systems for unemployment insurance and that sort of thing that were coded with COBOL 30 and 40 years ago, and suddenly they can't handle the scale that is suddenly being applied to them, and so they need COBOL programmers to come in and remediate those systems. Not unlike the fun we had with Y2K 20 years ago.
Was it really an issue, the Y2K? Was it, or was it just a scam which the programmers unleashed on the?
I don't think so. I think it was real. There were certainly a lot of applications that had two character fields for the year, and I think that was a big deal. But I think that there was enough urgency placed behind remediating all those systems that we came through mostly unscathed.
Yeah, I got the feeling too. But you're right. It was actually great exercise to create inventory of all your systems.
Yes.
In the office, in your company.
Yeah. That's a great point, because I know companies that never had a list of their applications, a database of the applications they had in house until Y2K came along and forced them to take one.
So, and that leads me to another question. The Y2K in my memory, and especially then what came after that, the dot-com bubble and the September 9/11, and it was a time where suddenly kind of it was wake up after drinking night, where everybody was just drunk from the latest and greatest technology, and came back the realization that we have to really focus on business. And from your memories, from your experience, how was it that the technology suddenly started really contributing to business? Like, because there was the switch where I remember before, I can really call before 9/11 and after 9/11. Before 9/11, people would come to me and say, we need the latest version of this software. We need, install. How come we don't have it yet? It should be on all our workstations. And that was the mantra of the day. And then came 9/11 and everything froze. And suddenly people say, we need to run business. And then there was the realization that the technology has to support business.
Right.
That was.
I think that's right. And I think, certainly one of the great challenges of enterprise IT departments is the growing partnership that they have to have with the business component of their organization. And what does that mean? Well, when you think about where computing was, a generation ago, computing really handled some of the busy work that was done manually. I have to tell you that one of my very first summer jobs when I was a kid was actually, I had literally a paper spreadsheet where I added up sales figures from gas stations, and they had to add up on this. It literally was a spreadsheet, but it was paper. Had to add them up across and add them up down and make sure the numbers all added up the same way. And when we first deployed mainframes and data centers and so forth, they were primarily used for rote functions like that to eliminate some of the big, some of the manual labor that had traditionally been involved with running a business. But what we've seen increasingly, and I think we're really hitting some new thresholds in this, is that technology really becomes the business. It's been said a lot within the last few years that every company is becoming a software company, and there's an element of truth in that. And when I think about what does that really mean, you think about the systems that support a large company, or any company really. In many ways, they define that company's competitive differentiation. So, for example, Sam's Club and Costco and Target and so on, they all have different business models. For some, it's driven by the primary source of revenue comes from subscription fees. From some others, it comes from margins on the products, and so on and so on. And all that's embedded into the systems that the company has deployed in their data centers or in the cloud. And so, if you think about it, really, that's really the business model of the company is actually embedded, programmed into these systems. And so, when I think about now, with every company requiring this level of technology to actually run their business, then in a lot of ways, the technology has become the business.
Totally. Yes, I haven't thought about it that way. Now you're describing, I totally see the change. Yes, thank you. Now, and that was again how technology can support the business and people, and I think that one of the disservices which technical people do either to themselves or to the business is that they don't want to, or they are not capable of learning actually the business and more importantly, even communication. How to communicate what the technology is capable, and then also how to translate the what the business requires into technology, how to create a mutual beneficial relationship. Because I think that, and I may joke about the Y2K, that it was a scam by the developers or programmers to scare everybody around them to create job for themselves. But this is one of the things which I'm observing within industry as well.
Well, I think that's right. And I think that the successful companies and the successful developers, the successful technologists will have a deep appreciation for how the business runs, what the business goals are, what the business strategy is, and so on. And so you can see that happening in several different ways. For example, I used to run the enterprise architecture department for a large technology company. And one of the things I used to say there is that the enterprise architects had to have one foot squarely planted in the business and another foot squarely planted in the technology. Be able to talk technology to business people in a way that they could understand and would see value, and be able to talk business to the technologists in a way that they could, they could see what it was their goals were, what their objectives were in building and deploying a particular technology. And so I think building those bridges is vitally important. But what we've seen actually, I think, over the last few years, which has accelerated that linkage between the two groups, is how easy it is, how straightforward it is to experiment in the cloud. And what I mean by that is, in the old days, if you wanted to deploy a new application, if you wanted to try a new technological capability, what did you have to do? Well, you had to buy a server, you had to get space in the data center, you had to provision operating system, deploy patches, and it was all very expensive and therefore very, very high risk. And so as a consequence, people wrote requirements documents and did analyses and build by analyses and so forth. And there was an awful lot of prep work that went in before the application was ever even procured. And there was a long, long cycle time. Now it's very easy with the cloud to simply rent that application, perhaps even over a weekend, and take it for a spin for that technology. You want to try machine learning, you want to try data lake in the cloud, you want to try you want to try containers or Kubernetes. Well, there's nothing stopping you. You can just try it very inexpensively, practically with zero risk. And the important thing is, you can bring your business people in to help you in a hackathon and watch it and see what the value is and understand it. And then suddenly the business people become your greatest allies. I have a story to tell about that. I was talking to a friend of mine in a large company, and he was saying that in the old days when they had a certain application in the data center, it would take a week to generate a particular report by running this algorithm through various data warehouses and so on. It would generate this report. And what they realized was that in the cloud, if they devoted 3x more servers to it, they could actually generate that report in an hour. It would cost a little bit more. But now you had a very interesting conversation with the business. You could say, what is it that you want in terms of business value? Is it worth it to you to get this report within a few hours, or are you okay waiting a week for this? And you suddenly have this much more of a direct cost versus value conversation with the business. And I think we're getting more and more to that these days, which is a great thing.
Again, 100% agree with you. I remember we had a customer at one point, and we had to put extra network card because of network security. Right. And it was a project for 6 weeks. I'm sure for some of the viewers and listeners they won't be able to understand that, but just to go through all the procurement process and paperwork, it was unbelievable. Yeah. Now, if I don't have server up and running in 6 minutes, I'm saying, what's wrong? Where's the hiccup? Is the internet slow, or what? Are we switching to different data center? How come?
Exactly.
So that, and you're right. And I think that the way how you describe it allows people to have unleash their imagination, because then they can start very quickly experiment with the what if scenarios almost instantly. Mm-hmm. And not being restricted by how many servers they need to have. It's just, again, we're moving back to the concept of mainframe. I don't know how many servers I'm using right now.
Yeah, I think that's a really good point. What's different now, I think, is as long as we've been in the software and hardware industries, we've always thought about limitations. When the TRS-80s came out, it was we had 64K of memory, and then the PCs came out and we had 640K of memory, and and all of our, and so on and so on, and our applications were always driven to a large extent by the constraints imposed on them by the hardware. Well, now it's much more interesting, because if you can master the concepts of distributed programming, you effectively have unlimited compute available to you, unlimited memory available to you, unlimited storage available to you. And that's a very freeing assumption. You can start really thinking about, well, shoot, if I have all that, if I have all that I need, how do I write an application that takes advantage of that? And what value can I provide back to a user if I don't have to worry about any limits at all?
Yes, and this is great shift, and this allows you to, again, focus on what's important, what value we will bring with the technology.
Yeah.
And we also mentioned the term communication. I think that would be very interesting if you can touch on your time when you try to communicate with animals using technology.
When I was in the developer relations group at Microsoft for a while, and we were using the Kinect 3D camera and high resolution microphones to attempt to decipher dog communication. And it was a fascinating topic. And this is an example of where ultimately we're probably pushing the bounds of the technology just a little too hard. We were able to make a considerable amount of progress, but we had to engage probably some of the very best machine learning and artificial intelligence engineers on the planet, and some of the very best developers. And as I say, we were able to make some progress. We were able to really see our way to achieving something within 3 to 5 years, but there were some problems. And one of the problems that we recognized was that of all the species we could have chosen, dogs were probably the hardest, because by far and away they have more. The interesting thing about dogs is, they communicate through gestures a lot. So you can tell, for example, if they wag their tail more to the right than the left, for example, that's a sign that they're very happy. So you can sort of decipher these little things, with the appropriate software. But there's so much variety in the size of a dog. Some dogs have tails. My dog doesn't have a tail. And there's so much, so many other variables that go into this equation that we figured it would probably take 3 to 5 years at least to get this going. And Microsoft, I think quite rightly, decided that the best use of all that talent was probably somewhere else. But but that's a case where we saw this and said, this is something that's possible. Maybe lit the way for someone to come once the technology advances a little bit further. So that's interesting. But I do think at the end of the day, if you look at dogs, and the dogs are different from a lot of animals in that they don't have a culture. When typically you get a dog, it's a puppy, and all that dog knows is your family, your behavior, and so forth. As opposed to you and I, we learn culture from our parents, we learn language from our parents. And so in a lot of ways, I think a more interesting selection might have been dolphins. They have very big brains. They clearly have a culture that's passed down from generation to generation. So maybe someday in the future, we'll be able to have a conversation with the dolphins in the city.
Funny you mentioned dolphins. I was just watching on YouTube documentary about adolescent dolphins, and the narrator was describing dolphins, teenage guys, no girls, just teenage guys, who were kicked out of the big pod by their mothers because they were unbearable. and this group of yahoos are swimming through the ocean, and they come across pufferfish. And what they do, and I didn't know, um, the pufferfish is can be very it's highly lethal. It's
Yes.
poisonous.
Yes.
Uh, and the dolphins, they know that, and so they very gently hold the fish, and they toss the fish over like a balloon,
Yeah.
and they gently chew on it, because the small amount of poison which gets into their bodies makes them high. So they use pufferfish, and they, right. So your parallel between dolphins and humans is I think very accurate, because at one point the parents, they kick the teenage kids out as well, because they cannot take it, right?
Well, I think that, the interesting thing is, I think from a technology perspective, we're seeing some interesting developments that may help us in this quest, and in a lot of others as well. For example, IBM has, well, actually, let me back up. We're seeing some actual breakthroughs and paradigm shifts in how we actually think about computing hardware. So, for example, IBM has a chip called the True North, which is effectively a neural network in silicon. And what that means is that it's what we call a non-von Neumann architecture. It doesn't have instructions and memory and processing in the traditional sense. It actually has little silicon neurons where signals come in, and they're processed by these little very simple little neurons. And if the activation energy is achieved, then it sends a signal to another neuron, and so on, just in the same sort of way that a human brain or an animal brain works. And what's interesting about that is those things are fantastic at pattern recognition. And of course, when we think about communications, we think about recognition, patterns are core to all of that. So, what we may be seeing now is the emergence of a new model for computing, which is based not on calculation, but more on pattern recognition, and will be applicable to the dolphins perhaps, and maybe a wide range of other scenarios as well.
I totally resonates with me. I think that I remember the days when we were guys, they were comparing how big is their car. We were comparing how strong our CPU is in our workstation, right? And how much memory we have. And if you ask me now what kind of CPU I have in my workstations, I don't even know. I really don't know. It's something, and it's adequate enough. And now the shift which I see, it's not this or that computing platform. I think it's always the combination of, because one thing which I definitely follow is the quantum computing. And when people are saying, well, quantum computers will be never fast as our regular computers, my answer to that is that's not the point, because they will be used for certain type of calculations which we cannot do with this architecture which we have in our workstations or servers. And the same thing goes to more pattern recognition chip from IBM.
Yeah, I think that's right. And I think that, from a megatrend perspective, I think what we're seeing is, and I wrote an article about this many years ago. It took longer to be realized than I would have thought. But, if we look at the cloud, we see this very homogeneous, almost like connected, almost like tissue, of all these, uniform, homogeneous devices all connected to one another, almost like, in the biological world, like jellyfish or another simple type of animal. But, with what we're starting to see now is the emergence of special purpose devices, in some ways like organs, if you follow the analogy. So like, quantum computers as one to do sort of combinatorial problems that are absolutely intractable on the classical computer. The neuromorphic chips like the True North or the Intel Loihi and others that do pattern recognition. Really high-end GPUs that do other kinds of pattern recognition and so on. So, I think, we're seeing this sort of, a new diversity in computing hardware and the fabric of our computers that is can be an interesting and I think really exciting trend that we'll see in our lives over the next 10 to 20 years, if not more.
And we see that even now within cloud, where again, before we would install certain type of databases and we would store the information. And the cloud allows you to completely obfuscate where you store the data. You know, we're using, again, I would say highly marketed terms like data lakes and things, right. But the concept behind it is you store the data, and actually, when is it that you don't care where it's stored? You just need to be stored, and you just need to retrieve. And you have you know, relational databases, you have NoSQL databases, you have graph databases, you have different type of databases, and they come and go perhaps, but for each type of when you need to store the information, suddenly you will create the layer which will decide where is the right place to store the information. You don't care anymore about it. The same way I need to make calculation, and whether it's happening, as you said, on GPU or regular CPU or quantum computer, again, it will become so irrelevant eventually.
Yeah, and what actually becomes the biggest value is the knowledge that you won't lose the data. You know, so when you think about cloud data, it's usually most storage in the cloud is backed up twice with dual redundancy. And so, you know, you can rest assured that you're not going to lose the data. AWS S3 has some amazing SLA around data loss. And you know, I think the other cloud providers are similar as well. But the key value proposition there is you're not going to lose the data when it's in the cloud.
Yes, and we will have all my pictures there forever. I know, but what a dream, right?
Right, exactly. Yeah. You'll always be able to retrieve them, whether you want to or not.
So, Barry, if somebody would like to be like you, have a successful career in technology and be able to work on these type of projects, what they should learn?
Well, I think beyond the basics of programming and computer architectures and computer science and so forth, I think the main thing that I would advise is that, or suggest, is that it's all about the passion. You know, it's you don't normally think of computing as being a very human activity, but in fact it is. I would say that, you know, the passion, the curiosity, the drive to try something new, to experiment with a new technology, to see if you can achieve a new result. I think if you have that, you know, and you follow your dreams and follow that passion, then you'll have a great career.
With that, we can finish our episode today with Barry Briggs. And Barry, if people would like to get in touch with you, how they can find you?
So my website is cleverly enough barrybriggs.com, and my Twitter handle is @BarryBriggs. So very easy, and I look forward to hearing from you.
Perfect. Thank you very much. Thanks for everybody for watching. Subscribe to our show. And until then, I'm your host, Václav Inchali. Thank you.